Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to start one of the most important chapter of organic chemistry, that is aldehydes, ketones and carboxylic acid. Okay, so this is a very high weightage topic and in your PU boards also this has very high weightage and a lot of reactions are there in this chapter, but many of the reactions are also some repeated reactions, right? So yes, now I want all of you to sit with a notebook and a pen so that you can note down all important reactions, you can write down all important reactions and you can memorize them very easily. Okay, after completing the lecture we will also be doing around 10 to 15 questions, we'll be practicing. Some of them will be PYQs, some of them will be other questions. Okay, and one more request, please join our WhatsApp channel. The link of the WhatsApp channel is there in the description section of this video. So if you join our WhatsApp channel, you can get access to the notes, the question papers, solutions, everything very easily through the WhatsApp channel. Okay, so please do not forget to join the WhatsApp channel. Okay, so in today's lecture we will be going to talk about aldehydes, ketones and carboxylic acid. So in this chapter aldehydes and ketones are studied together, carboxylic acid is studied separately, right? So today we are going to discuss nomenclature, structure and preparation for aldehydes and ketones part. Okay, only aldehydes, ketones, nomenclature, structure and preparation we will discuss. Okay, I'll tell you how we are going to cover this chapter. This is what is very important to understand. When you revise, you must keep in mind what are the different topics that is present in this particular chapter. Okay, so today is part 1, so I'll be covering this chapter in 4 parts. So in the first part we are going to discuss today aldehydes and ketones. Under aldehydes and ketones, nomenclature, structure and preparation of aldehydes and ketones. Okay, a very important topic. Next, coming to part 2, in the next lecture we will be talking about physical properties, chemical reactions of aldehydes and ketones. Okay, next we'll also, okay, so this is your physical properties already done. Okay, next coming to in part 3 for carboxylic acid we'll be talking about nomenclature, structure and the method of preparation. Then in the last lecture we'll be doing physical properties and chemical reactions of aldehydes and ketones. Okay, so there are 10 topics. Okay, so if we remove this one, just so we will get here 6, 7, 8, then we have here 9 and here 10. Okay, physical properties and chemical reactions in the second lecture of aldehydes and ketones, and part 3 and part 4 will be dedicated for carboxylic acid. Clear? Okay, now coming to the weightage of this chapter. So this is a very high weightage topic. You can see 3 questions, 4 questions, 5 questions, 2 questions. So you can say that like an average of 3 to 4 questions you can easily expect from this chapter, right? 3 to 4 questions are very easily we can expect from this particular chapter. Okay, now we'll go to the next part, that is today's first lecture. What all things we are going to cover? As I told you, today will be nomenclature, structure and the preparation of aldehydes and ketones. Under preparation of aldehydes and ketones, we have preparation of aldehydes and ketones, preparation of only aldehydes and preparation of only ketones. Okay, so preparation, first of all we'll talk about nomenclature, structure, and then under preparation we have 3 categories. Preparation of some methods which is common for both preparation of aldehydes and ketones, second only specific to preparation of aldehydes, and third only specific to preparation of ketones. Okay, so now let us move forward with the first topic, that is nomenclature. So under nomenclature we have again 2 categories here. One is your common name, another is your IUPAC name. Okay, so for common name you must remember certain examples. Like for example, this is your ethanol, right? It is called as acetaldehyde. So here I'll tell you for IUPAC name. Okay, for IUPAC name, for aldehydes the ending part or the name ends with the letter Al. Okay, and for ketones the name ends with the suffix One. Okay, so you can see here there are 2 carbons, so that is why it is eth, and then ethane 2 carbon, and aldehyde Al it will end, so the IUPAC name will be ethanol. Okay, Okay, next one, benzene with CHO, this is benzaldehyde. Okay, next, this is very important. See, the carbon which is next to the carbon containing the aldehyde group, that carbon is called as alpha carbon, okay, and next to that beta, and next to that is your gamma carbon. Now this bromine is present in the beta carbon, right? So we can say beta bromo, okay, then beta bromo butyl aldehyde, okay, butyl, because why? We have 4 carbons, 1 2 3 4, so butyl aldehyde, beta bromo butyl aldehyde, okay, that is the common name. Okay, so these all are your, we are discussing now common names. Okay, we'll also talk about the IUPAC name, but common names are very, very important. These 4 common names are very important. Okay, so now you can see this acetone is your ketone group, okay, common name of ketone. Here acetophenone, aceto stands for this group and phenone stands for this group. Next propiophenone, so phenone is this one, propio group is this one, right? Next you have benzophenone, so benzophenone, propiophenone, benzophenone, acetophenone, acetone. These are some of the common structures which are very, very commonly asked. So you must remember acetone, acetophenone and benzophenone. These 3 structures are very important, okay, please draw it. Okay, now coming to the IUPAC name, okay, so we are discussing both common name and IUPAC name, okay. So for example, if you have first one, that is HCHO, that is with 1 carbon, right, aldehyde group with 1 carbon, so that will be called as methanol, okay, and its common name is formaldehyde. Now if you see aldehyde group with 2 carbons, that is ethanol, okay, ethanol ending with AL, and the common name, as we told, it is acetaldehyde, okay. Next if you see this one, we have CH3, C, then we have CH, COH, okay, sorry, one more extra carbon I did. So we have here, okay. So now if you see here this carbon, okay, if you see numbering 1 2 3, so 2-methyl propanol, 2-methyl propanol is the what I say IUPAC name. Now if you see common name, okay, so this is a group, isobutyl group, this one if you know, we have this one is isobutyl group, so isobutyl aldehyde, okay, isobutyl aldehyde structure, okay. Next if you see this one, this is 3-methyl cyclohexane carbaldehyde, okay. This is very important, that with cyclic rings, okay, with cyclic rings we use the word carbaldehyde, okay, please note down this one, this is important, note here, with cyclic structures the name used is carbaldehyde, okay. So now if you see this is 1 2 3, so 3-methyl cyclohexane carbaldehyde, 3-methyl cyclohexane carbaldehyde, okay. Now if you talk about its common name, right, so common name, if you see this is first carbon, alpha, beta, this is gamma, right, so gamma methyl cyclohexane carbaldehyde, okay. Next one if you see, next we have functional group attached, so let me erase this one so we can understand these examples better. So first note, you have written that with cyclic rings we have to use carbaldehyde name, okay. Next if you see we have CH3, okay, COCH3, then CH, and then we have CHO, okay. So now if you see here, this is your alpha carbon, this is beta carbon, right. So alpha methoxy, this group is OCH3, OCH3 is your methoxy group, right. So that is why alpha, we have alpha methoxy, and then this one is propanol, okay, propione aldehyde, common name will be propione aldehyde, and if you see IUPAC name 2-methoxy propanol, okay. Next one very simple, 1 2 3 4 5, okay, so that is pentanol, pentanol common name used is Valor aldehyde, okay. Next if you see we have CH2 CH CHO, this is CH2 double bond CH COH. Okay, so this is your prop 2En, 1 2 3, right? Prop 2En Al, then ending should be with Al. Prop at 2 position we have double bond, and then Al will be the ending to denote that it is a aldehyde group. Now the common name here is very important, acrolein. The common name here is acrolein. Okay, that is again very important. Next you have benzene with CHO2 groups, so benzene 1,2 dicarbaldehyde. Okay, and the common name here is thaldehyde. Okay, next if you see this one, 1 2 3, so 3 bromo benzaldehyde, and or you can write 3 bromo benzene carbaldehyde, both are correct. Here meta bromo benzaldehyde. Okay, now coming to ketones. Ketones are like the if you have a ketone group, how the common name is given. So see, for ketone group we have that on the both sides of oxygen. Okay, so we have like this, for example, yeah, you have CH3, C double bond O, CH2, CH3. So you can name this part, and this part is called as ketone. Okay, so like for example, this I can write it as ethyl, methyl ketone. Okay, this is common name. But if we name it IUPAC name, so I can just number 1 2 3 4. So butane, right? Then 2 ONE, butanol. Okay, so that is what is given here, pentane 2N, methyl N propyl ketone. Now similarly you can have different groups here also, like you can see alpha methyl cyclohexanone, 2 methyl cyclohexanone. But remember, with ketone group, if it is a cyclic ring, the name is simply ending with ONE. But in case of aldehyde, the name has to end with the word carbaldehyde. Okay, now so I hope these are the different examples you can just see in your NCERT book. Okay, so now coming to the structure of carbonyl groups. This is very important. So now first of all you see that carbon forms in this carbonyl group, there is 3 sigma bonds. Okay, like suppose here there is R and here there is R. So this carbon is, what is the hybridization of this carbon? sp2 hybridized. So that means what? If it is sp2 hybridized, then it has 3 sp2 hybrid orbitals, 3 sp2 hybrid orbitals. Okay, so you can see this is one sp2 hybrid orbital. I can draw it like this. This is one sp2 hybrid orbital, this is another sp2 hybrid orbital, and this is another sp2 hybrid orbital. Okay, now these hybrid sp2 hybrid orbitals are used for which type of bonds? These are used for forming sigma bonds. Okay, so with this RR there is one sigma bond, with the oxygen there is one sigma bond. Okay, now there is between this C and O there is one pi bond also. Okay, so the pi bond formation takes place with the unhybridized orbital. Okay, so there is one unhybridized orbital here of carbon and oxygen p orbital. So carbon p orbital and oxygen p orbital under the unhybridized orbital of p of carbon and the p orbital of oxygen undergoes overlapping to form a pi bond. Okay, now what you should remember here, that this is a planar molecule. You can see the molecule lies in one plane. Okay, the carbon, the 2 bonds and the oxygen lies in one plane. Okay, and what is the bond angle here? The bond angle is 120 degree. Okay, so these 3 things are important, that what is the hybridization of carbon? Carbon hybridization is sp2 hybridization. Okay, next it forms how many sigma bonds? It forms 3 sigma bonds. Okay, next very important thing here is the molecule is planar structure. Okay, now coming to the bond is polarity of the bond. So if you see, oxygen is more electronegative, delta negative, and this one gets delta positive. This electrons shifts here, so we get CO minus and C plus. Okay, so whenever there is an attack, so this carbon I can say this is electrophilic in nature. So if you have a nucleophile or anything, it can attack on this electrophilic carbon. Okay, so we'll see a lot of reactions where the nucleophile attacks on the electrophilic carbon. Okay, so that is about the structure. Okay, now let us do some questions here. So names have been given and you need to draw the structure for them. Okay, common names have been given. So let us draw it. First, whenever you draw, you see the parent name. What is parent name here? Propione aldehyde. Propione aldehyde means propanol, right? So first we will do propione aldehyde. So I have like this. Okay, now you see alpha methoxy. So the carbon next to the aldehyde group is alpha carbon, and here we have methoxy group. So that is OCH3. Okay, next just balance it with hydrogen. So here I'll have one H and here it is COH. So alpha methoxy propione aldehyde. Okay, first structure is clear. Next one, let us try the second one here. Second one is 3-hydroxy-butanol. So first do the parent name butanol. So butanol means 4 carbons. Okay, 3-hydroxy. So 1, 2, 3. 3-hydroxy means OH group is there. Okay, then you can balance it CH3, CH, CH2 and COH. Okay, 3-hydroxy-butanol. Next is 2-hydroxy-cyclopentane carbaldehyde. So this is very important. First cyclopentane is there, carbaldehyde is there, right? This is done. 2-hydroxy. So on the second position we have OH group. So 2-hydroxy-cyclopentane carbaldehyde. Okay. Next one, if you see 4-oxopentanol. So pentanol means again 5 carbons. Okay. So 1, 2, 3, 4. So we have 4-oxopentanol. Okay, 4-oxopentanol. Next we have di-secondary butyl ketone. So I told you when ketone is there, okay, di-secondary butyl means on the both sides of ketone there is secondary butyl group. So if you remember what is secondary butyl group, we have, right, secondary butyl, no? This is isobutyl. Yeah, so we have this structure. Okay, so this is di-secondary butyl. You can just balance it with hydrogens. Okay, di-secondary butyl ketone group. Okay, next coming to sixth one, 4-fluoroacetophenone. So if you remember, I told you to remember the structure of acetophenone. So acetophenone is this one, right? 4-fluoro. So 1, 2, 3, 4. Here fluorine group. So this is 4-fluoroacetophenone. Clear? So I hope all the structures you have drawn. Okay. Now let us go to the very important part, that is preparation of aldehydes and ketones. So as I told you, here we will be studying 3 types of preparation. First, some methods of preparation which includes both preparation of aldehydes and preparation of ketones. Okay, same methods or same reactions for both aldehydes and ketones. Second one is preparation of only aldehydes. Third one is preparation of only ketones. Okay. Now coming to here, preparation of both aldehydes and ketones. Here what all reactions we have? First one is by oxidation of alcohols. Okay, first one is by oxidation of alcohols. Next we have by dehydration of alcohols, and next we have from hydrocarbons. Okay, so under next coming to preparation of only aldehydes. So preparation of aldehydes we have from acid chlorides, from nitriles and esters, and then we have from hydrocarbons. Okay, now coming to preparation of ketones. So here also first one we have from acyl chlorides, next you have from nitriles, and then we have from substituted benzene. Okay, so once again let us revise. Preparation of aldehydes and ketones we are studying under 3 categories. First, some methods where both aldehydes and ketones can be prepared using the same reagent. So preparation of aldehydes and ketones, both aldehydes and ketones. For that we have, what are the methods? Oxidation of alcohols, then we have reduction, dehydration of alcohols, and then we have last one from hydrocarbons. Okay. Now coming to preparation of only aldehydes. So here we have from acid chlorides. Okay, first one from acid chlorides, then second one we have from nitriles and esters, and last one from hydrocarbons. Now coming to only ketones, here also first one is from acid chlorides, next from nitriles, and third one from substituted benzenes. Okay, benzene or substituted benzene. Okay, once again let us revise. First we have preparation of both aldehydes and ketones. Where preparation of both aldehydes and ketones are there are three sources. First one is your oxidation of alcohols, second one dehydration of alcohols, and third one is from hydrocarbons. Next, preparation of only aldehydes. Here again we have three methods. First one is from acid chlorides, second from nitriles and esters, third one is from hydrocarbons. Next, third one, preparation of only ketones. Here again we have three things: from acid chlorides, from nitriles, and from substituted benzenes. I hope this part is completely clear. Okay, now if we move further, if you see, from hydrocarbons, again we have two methods from hydrocarbons. One is your ozonolysis, next we have hydration of alkynes. Ozonolysis and hydration of alkynes. Okay. Now coming to here, again from hydrocarbons we have oxidation of methyl benzene, chlorination of side chain, and Gattermann-Koch reaction. Okay. So I'll tell once again, we have three methods of preparation. First we are studying is preparation of both aldehydes and ketones. Under that, first is we have oxidation of alcohols. Second we have dehydration of alcohols. Third we have from hydrocarbons. From hydrocarbons we have ozonolysis, first one ozonolysis, and next one is hydration of alkynes. Okay. Next, coming to preparation of only aldehydes, there we have from acid chlorides, from nitriles and esters, and from hydrocarbons. Again here from hydrocarbons there we have three categories. First one is your oxidation of methyl benzenes, second one we have chlorination of side chain, and the last one Gattermann-Koch reaction. Then preparation of only ketones, here we have from acid chlorides, from nitriles, and from substituted benzenes. Okay, so this one you remember. For preparation of only aldehydes from hydrocarbons, we have three methods. What are they? They are oxidation of methyl benzenes, chlorination of side chain, and Gattermann-Koch reaction. So now we are going to study 3.1, 3.2, 3.3 separately. Okay, so this chart you must make, okay, so that you can have a quick revision what are the methods of preparation of aldehydes and ketones. Okay, so coming to the first one, that is preparation of both aldehydes and ketones. So as I told you, first method we have here is by oxidation of alcohols, by dehydration of alcohols, and then from hydrocarbons. From hydrocarbons we have two things, that is ozonolysis and hydration of alkynes. Okay, we'll come back to this after we have revised this part. Okay. Okay, so as I told you, first one from preparation. So first method here, this is your first method, number one, that is from oxidation of alcohols. Oxidation of alcohols. Okay, now here you can see that this is your primary alcohol and this is secondary alcohol. So remember here, primary alcohols will give you aldehydes, okay, and secondary alcohols will give you ketones. Okay, so for oxidation we can use mild oxidizing agent. What are these mild oxidizing agent? You can use PCC or you can use CrO3. So for oxidation of primary alcohols and secondary alcohols, we need mild oxidizing agents. What are the mild oxidizing agents that we can use? PCC or CrO3. So this reaction, if you remember, we have already studied in the alcohols chapter, right? So yes, so now primary alcohols will give you aldehydes with PCC or CrO3, and secondary alcohols will give you ketones with PCC or CrO3. Okay, just if I do one example, we can see, okay, so if you have like CH3, CH2OH, okay, and you treat it with PCC, so we will get CH3COH, right? Next, coming to dehydration of alcohols. So under dehydration of alcohols, again we have primary alcohols and secondary alcohols. Okay, so primary alcohols with copper at 573 Kelvin will give you aldehydes. Secondary alcohols with copper at 573 Kelvin will give you ketones. Okay, so primary alcohols will give you again aldehydes, and secondary alcohols will give you ketones, right? So this is your second method, that is, what is the second method name? Second method is dehydration of alcohols. What is the reagent for here? Reagent is copper at 573 Kelvin. Okay. Now coming to third method, that is from hydrocarbons, right? From hydrocarbons. And from hydrocarbons, the first method that we have done is your ozonolysis. Okay. Now what is, or you can call it as reductive ozonolysis. Okay. More specific if you go, it is reductive ozonolysis. So what is the reagent required for reductive ozonolysis? O3 and zinc water. Okay, O3 and zinc water. So when we treat this one, what happens? This bond breaks. Okay, just you have to break this double bond, and you have to add oxygen on this side and oxygen on this side. Okay, so I'll tell you one example here. So let us do with an example. So suppose I have CH3, CH double bond CH2, and then you have suppose O3 with zinc water. Okay, then what will happen? First you can just break this double bond. Okay, then add oxygen on both sides. So what I'll get here? CH3 CH double bond O plus. So I just added, this double bond is here, I added oxygen on this side, and here it is C double bond O H H. Okay, so now this is how reductive ozonolysis work. Okay, next coming to that, first one was ozonolysis, then the second one was hydration of alkynes. Hydration of alkynes. Okay, so here what happens when you add H2O in presence of H plus and Hg2 plus, water is added following Markovnikov's rule, means OH and H is added following Markovnikov's rule, and then there is tautomerization. Okay, so we'll do with an example. So let us take like this, we have CH3 C triple bond CH. Okay, you treat it with H plus, this reagent, that is your water in presence of H plus and Hg2 plus. So here Markovnikov's rule will be followed and OH and H will be added. So this carbon has less number of hydrogen, so OH will be attached to this carbon. So what I'll get? CH3C, I'll add here OH and H. Okay, one second. Yeah, so we can add here OH and we'll add here H. Okay, then what happens? Then something called as tautomerization takes place. Okay, so this part will get converted to double bond and this part will get converted to single bond. So we will get here CH3, okay, C double bond O and then CH3. Okay, so this is called as this method is called as tautomerization. Okay, whenever there is enols. Okay, what is enol? You can see this En stands for double bond and OL stands for alcohol. Okay, so whenever there are enol group, there is tautomerization to give you aldehydes or ketones. Okay, so all the three methods are clear here. First one is your oxidation of alcohols. So oxidation of alcohols, primary alcohol will give you aldehydes, secondary alcohols will give you ketones. For oxidation, what are the reagents we can use? PCC or CrO3. This is done. Next is dehydration of alcohols. Again here primary alcohols will give you aldehydes, secondary alcohols will give you ketones. For dehydration, what is the reagent required? Copper at 573 Kelvin. Okay. Next, the third one is from hydrocarbons. Okay, so under hydrocarbons we have two things. First is your ozonolysis of alkenes. This is very easy. In ozonolysis of alkenes, what is the reagent required? O3 and Zn water, zinc water O3. Okay, so just you have to break the double bond, add oxygen to both the sides. Okay, Next, from hydrocarbons, the second part is from hydration of alkynes. So here we have to add water in presence of H plus and Hg2 plus. So this will follow Markovnikov's rule, addition of water following Markovnikov's rule, and then there is tautomerization to give you aldehydes or ketones. Clear? So these are the methods of preparation of both aldehydes and ketones. Okay. Next, coming to preparation of only aldehydes. Okay, so here if you remember, we have discussed there were three methods from acid chlorides. First one is from acid chloride, second one from nitriles or esters, third one is from hydrocarbons, right? Again, under hydrocarbons we were having three reactions, right? So let us see this. So preparation of alcohols, first one is from acyl chlorides, next one is from nitriles and esters, third one is from hydrocarbons. Now under hydrocarbons we have another three methods. Okay, so from nitriles and esters we have the name reaction, what is Stephan reduction, and we have another dibyl H. We'll discuss this. Okay, then from hydrocarbons we have oxidation of methyl benzenes, then we have chlorination of side chain, and we have Gattermann-Koch reaction. Now under oxidation of methyl benzenes we have Itard reaction and we have use of CrO3. Clear? I think this is little big one, but let us discuss it again. First, preparation of only aldehydes, we have three methods. From acid chlorides, first one. Second one from nitriles and esters. So from nitriles whatever is done, that reaction is called as Stephan reaction, and a reagent used from nitriles and esters to convert to aldehydes is dibyl H. These are two different reactions where we can get your aldehydes. The third one is from hydrocarbons. So under hydrocarbons first we have from methyl benzenes. So in methyl benzene again we have two things, one is your Itard reaction, another is using CrO3. Okay, and then we have the second one is from your chlorination of side chain, and last one we have Gattermann-Koch reaction. Okay, so now we will see. So you can see just here 1, 2, 3, 4, 5, 6, 7 reactions are almost there. Okay, so we will study all of them in detail. So you can see all the reactions I have written in one single page. So you should draw this diagram. This will be a mind map, a flow chart where you can revise all the reactions of preparations of aldehydes quickly. Okay, so first one was what? From acid chlorides. So we'll see this one is your first method, number one from acid chlorides. Okay, so you can see this group COCl, RCOCl, this group is called as acid chlorides. So here if you treat with H2 palladium barium sulfate, then we will get this Cl group will be replaced with H group. Okay, so if you treat this one, then I will get here benzene ring with CO and H. Clear? Now this reaction has a name reaction, means it has a particular name for this particular reaction. This reaction is called as your Rosenmond reaction. Rosenmond reaction. Okay, the first reaction clear from acid chlorides. Okay, one second. So first reaction is from acid chlorides. We have RCOCl. Reagent to be used is H2 palladium with barium sulfate. In this Cl will be replaced with H. Okay, RCOH. Now this reaction is called as Rosenmond reaction. Okay, now coming to the second one from nitriles and esters. Okay, so now see, from nitriles means your RCN. Okay, so this is your second method, that is let me note down here, second one from nitriles. Okay, so now from nitriles means RCN, you can take this reagent SnCl to HCl. Okay, what will this do? This will reduce this one to give you imines. Okay, so just you can imagine you have to add 2H to both. You add one H here and add one H here. So we will get imines. Okay, now if you do hydrolysis, what will happen? This part gets converted to O. Okay, if you do hydrolysis, this NH vanishes and in place of that oxygen comes. Okay, so if we take this one H3O plus, I will be getting here RCH double bond O. Okay, so this method, this reaction, first we are taking nitriles, then we are treating with SnCl to HCl, then we get imines, and then we treat with hydrolysis, we get aldehydes. So this method or this particular reaction is called as Stephan reaction. Okay, another name reaction here, Stephan reaction. Okay, now from the same nitriles RCN, we can use another reagent, that is dibutyl H, diisobutyl aluminium hydride. Okay, it looks like this, aluminium hydride and two isobutyl groups are attached. So dibutyl H in water will also give you RCHO. Okay, and if you take from esters, okay, from nitriles and esters we had, right? So with esters also, if you treat dibutyl H in water, we will get aldehyde group. So this part will vanish and here H will come, RCOH. Clear? Similarly here what will happen? RCN will get converted to RCOH group. Clear? So let me revise again. First one is from acid chlorides. So with acid chlorides, the first method you have to use H2 palladium barium sulfate. Chlorine will get replaced with hydrogen. This has a name reaction called as Rosenmond reaction. Okay. Now second one is from your nitriles and esters. So from nitriles, first method, from nitriles we have two ways. Okay. One is you treat nitriles with SnCl2 and HCl. Then we get imines, and then you do hydrolysis, we will get aldehydes. This reaction is called as Stephan reduction. Okay, this reaction only is called as Stephan reduction, where we used SnCl2 and HCl. Next what we can do, we can take the same nitriles and treat it with another reagent, that is dibutyl H, diisobutyl aluminium hydride in presence of water. This one will also give you aldehydes. And another one what you can take is your esters. With esters also, if you do dibutyl H and water, we will get aldehydes. Okay, so by now we have completed the two methods. Third method is from hydrocarbons, right? So from hydrocarbons, if you see, okay, so this one, this three method, 1 and then we have 2, this 3 and this 4, these all are from hydrocarbons. Okay, so I'll write here, third one is from hydrocarbons. Okay, now coming to first one, this one is your Itard reaction. Okay, this one is your Itard reaction. Now what is taken here? From methyl benzene, you can see methyl benzene, you treat it with chromyl chloride, that is CrO2Cl2. You treat it with CrO2Cl2 in presence of CS2. CrO2Cl2 in presence of CS2. So this one will give you a chromium complex. This is a chromium complex. Okay, in this complex you have OCrOHCl2 twice, OCrOHCl2 twice. Okay, so this one under hydrolysis if you do will give you CHO. This whole thing will be removed with one oxygen. Okay, that is the first one. From Itard reaction, so here we have, this one is from methyl benzenes, from methyl benzene. Okay, so under from hydrocarbons, first one is from methyl benzene. Under methyl benzene we have two methods. One is your Itard reaction. Now here 1B I can write. Okay, 1B, that is using CrO3. Same, you have to take here methyl benzene, treat it with CrO3. So you will get in presence of this anhydride group. So we'll get CHOCOCH3 whole 2. Then again you do hydrolysis, we will get aldehyde group. So this part will be replaced with O. Okay, so you have to take chromium oxide with O anhydride, that is CH3CO whole 2O. This will give you CHOCOCH3 whole 2, and then you do hydrolysis to get aldehydes. Okay, so this is the from hydrocarbons, the first one from methyl benzenes. Under that we have two, Itard reaction and using CrO3. Next, coming to the third one is the second one is your chlorination of side chain. So this is your second method. Okay, 3,2. 3,1 is methyl benzene, 3,2 is from chlorination of side chain. Chlorination of side chain. Okay, so first of all, what we do here, you just treat it with chlorine H nu. So here 2 hydrogens will be replaced with 2 chlorine. Next you treat it with water. So here what will happen, this Cl2 group, so if I draw here, this one will get converted to CH and we have 2 OH group here. So now you know on one carbon 2 OH group is not stable, so there will be dehydration, and due to that dehydration we will get RCHO. Okay, this is the second method from your hydrocarbons. Okay, now coming to the third one, the name reaction. Okay, this is your Gattermann-Koch reaction. Gattermann-Koch reaction. So here you take benzene, then treat it with COHCl in presence of anhydrous AlCl3 or anhydrous copper chloride. Okay, CuCl or AlCl3. CO in presence of HCl. So this one will give you RCHO, Gattermann-Koch reaction. Clear? So I know a lot of reactions are there, a little confusing, but do not worry, we'll practice it again. Okay, we'll do it again, draw it again and revise all of them. So first let us have a oral revision here. First, only aldehydes. We have first method is from acid chlorides. Simple acid chlorides, treat it with H2 palladium barium sulfate, we will get RCOH. This reaction is called as Rosenmond reaction. Second one is we have from nitriles and esters. So from nitriles, if you treat it with SnHCl and then we'll get imines, and then we do hydrolysis, we get aldehydes. This is your this is your Stephan reduction. Next, from the same nitriles, you can treat it with diibal H, that is diisobutyl aluminium hydride and water to get aldehydes. Or you can take esters and treat it with diibal H and water, you will get again aldehydes. Okay. Third one is from your hydrocarbons. Under hydrocarbons, first one is from methyl benzene. In methyl benzene, you treat it with this one, that is CrO2Cl2CS2. So this will give you a chromium complex. Then after that you do hydrolysis, we will get aldehyde. This is one method. Or from the same methyl benzene, you use chromium oxide in presence of acetic anhydride. This will give you a complex, and again with hydrolysis we will get RCHO. Okay. Now coming to the third one, that is your from coming to the from hydrocarbons, in that the second part, that is by chlorination of side chain. So here you have methyl benzene treated with chlorine H nu, you will get 2 chlorine. Treat it with water, this chlorines will be replaced with OH, and you know on single carbon OH is not stable, so there will be dehydration, and because of that we will get aldehyde. Okay. And then the third method under from hydrocarbons, that is your benzene COHCl, anhydrous copper chloride or anhydrous AlCl3. Okay. So this will give you benzaldehyde. Clear? So these are the different methods of preparation. Now I have left this blank slide so that we can revise it again. Okay, so that again we can do a proper revision of the methods of preparation. So I'll just write down first, we need to prepare this one, right? Benzaldehyde we need to prepare, any benzaldehyde or normal RCHO. So the first method I have is, first method is from acid chlorides, from acid chlorides. And what is this method name reaction? This is a name reaction and we call it Rosenmond reaction. Okay, so here what I have to take, so let me draw this little down. So we have here, okay, so first method, you can tell me the reagents here. So what is the reagents required? So we have R from acid chlorides, right, RCOCl in presence of H2, then we have palladium and barium sulfate. Okay. Now coming to the second one is from nitriles. Okay, so I'll write like this, from nitriles. So if you remember from nitriles what we can do, we have from nitriles A, that is your Stephan reduction, Stephan reaction. So you can use RCN, then you have to use SnCl2 and HCl. So this will give you imines, right? After you get imines, just treat it with hydrolysis. It will give you, again benzaldehyde will get. Now another method you can do from nitriles, you can treat it with dibyl H. Okay, dibyl H with water. This will also give you aldehydes, right? Now second one I'll make, this is 2,1 from nitriles, and I'll make 2,2, that is from esters. So if I have R, C, O, O, R dash, right, from esters, and if you treat it with same dibyl H and water, this will give you aldehyde. Okay, so this method is done. Now coming to the third method, okay, is from hydrocarbons. Okay, from hydrocarbons, and under hydrocarbons, first one we have is from methyl benzenes, right? So from methyl benzene we can draw like this. First one, methyl benzene. You can use one reagent, that is your, I am writing directly, CrO2 Cl2 in presence of CS2, and then you use H3O plus. Okay, so first one chromium complex will form, and then after hydrolysis we will get benzaldehyde. And another way we can do is your CrO3, okay, in presence of CH3CO whole 2O anhydride, and then H3O plus, right? So this is from methyl benzene, both of this will give you benzaldehyde. Next, coming to your from methyl benzene, okay, that is chlorination of side chain. So this is second one, chlorination of side chain. Okay, so here if you treat it first with chlorine H nu, so we will get CHCl2. Okay, then you can just do hydrolysis. So here what will happen, both the chlorine groups will get converted to OH, and on the single carbon OH is not stable, so that is why there will be dehydration and we will get benzaldehyde. And the last one is your Gattermann-Koch reaction. So just you have to use benzene. With benzene you treat it with CO HCl in presence of anhydrous AlCl3 or copper chloride, right? So this is also a name reaction, and if you remember, this name reaction is called as your Gattermann-Koch reaction, third one. Okay, so these are all. So this is what we did. Now let's revise, right? Revision. Quickly we have studied and we have revised also in 1 minute. Okay, so done all the methods of preparation of aldehydes. I hope it is clear, and you can make this flowchart again and again to revise. Okay, so it will just take you hardly 5 minutes to draw these all methods, but once you draw it again and again, you will be more clear with the reactions. Okay, and one more thing I forgot to tell, this one is your Itard reaction. Name reactions are very important. Okay, fine. Now coming to the next one, that is preparation of only ketones. Okay, so under preparation of only ketones, we have first one is from your acid chlorides, next we have from nitriles, okay, and then we have from substituted benzenes. Okay, so let us see them quickly. So if you see from acid chlorides, okay, so the first method here is from acid chlorides. Okay, so from acid chlorides you have to take a reagent, that is dialkyl cadmium. Okay, dialkyl cadmium group. So now what will happen, this R will replace this chlorine. Okay, so you can see here, let me make it like this, this is R dash, so this is your R dash, and this R has replaced this chlorine to give you RCOR, like this is your ketone groups, right? So the now coming to the second method is what, from nitriles. So this is little important one. So here we use dialkyl cadmium, right? We use dialkyl cadmium compounds. Here with nitriles we use Grignard reagent. Okay, we have to use what? We have to use Grignard reagent. Now if you remember Grignard reagent, I told you there is plus minus. So here what is there? Nitrogen is plus, carbon is, so nitrogen is more electronegative, so it will have negative charge and carbon will have positive charge. Now here if you see magnesium is positive, this alkyl group is negative. Now you know very easily what you have to do. Minus will attack on the plus and plus will attack on the minus. So there will be one bond, the bond will break. Now this plus will take this minus, that is C6H5, and this N minus will take MgBr, that is MgBr. After that what you have to do? After that you have to treat it with water, acid hydrolysis you have to do. With acid hydrolysis what will happen? This whole thing will vanish and will be replaced with one oxygen. Clear? Very simple. Here with nitrates we have to treat Grignard reagent and H3O plus to get ketones. Okay. Next, the third method was your from benzenes or some substituted benzenes. Okay. So from benzenes, this is very simple one. This reaction RCOCl AlCl3. So you must remember this is your Friedel-Crafts reaction, right? Friedel-Crafts reaction. So here what will happen? COR group will be attached. So if for this one we will get benzene ring, with that we will have CO and R group, right? So these are the methods of preparation from three parts. First is from acid chlorides, you have to use dialkyl cadmium. Next, from nitriles we have to use Grignard reagent and hydrolysis. The third one is from benzenes or substituted benzenes, and you have to simply do Friedel-Crafts acylation. Okay, Friedel-Crafts reaction. Clear? So now we can have one more round of revision before going to practice questions. Okay, so let us recall all the things quickly. So we'll go to the first page where we have written all the reactions, and then we can remember here. Yeah, I want this page we can use for revision. Okay, so first one, preparation of both aldehydes and ketones by oxidation of alcohols. What are the reagents required here? You can use PCC or you can use CrO3. I hope you remember this one. And here what is there? Primary alcohols will get converted to aldehydes and secondary alcohols will get converted to ketones. Next, by dehydration of alcohol, here the reagent is copper at 573 Kelvin, right? Again, primary alcohols will give you aldehydes, secondary alcohols will give you ketones. Now coming to from hydrocarbons, under hydrocarbons we have ozonolysis. What is the reagent for ozonolysis? For ozonolysis it is O3 and zinc water, right? O3 and zinc water. So what we have to do here? You have to divide the double bond and add oxygen on both sides. Next, coming to hydration of alkynes, right? So coming to hydration of alkynes, you have to add water, okay, in presence of H plus and Hg2 plus. H plus Hg2 plus. So here OH and H will be added following Markovnikov's rule, and after that there was tautomerization. Okay, I hope this part you remembered. Now coming to preparation of only aldehydes, right? So if you want preparation of only aldehydes, so first one we used was from acid chlorides, right? So from acid chlorides, what was the reagent? H2 palladium barium sulfate, and this name reaction was Rosenmond reaction. Okay, Rosenmond reaction. Next, coming to from nitriles and esters. So if you remember, with nitriles, okay, with nitriles we have two reagents. One was your SnCl2 HCl, and then you will get a imine, then you have to do H3O plus. This name reaction was your Stephan reaction, right? This was your Stephan reaction. So I am just writing for revision. Okay, so don't think that I have missed many things, but it is only for revision, quick revision. Next, if you see from esters, you should also practice with me. Now another was here was dibyl H with water. So whether you have this one or esters, we can get here your aldehydes. Okay, next coming to only like from hydrocarbons. So from hydrocarbons by oxidation of methyl benzene, here we have two things. One was CrO2Cl2 in presence of CS2. This reaction was called as, name of this reaction was Itard reaction. And we can also use CrO3 in presence of CH3CO whole 2O anhydride. Right. Next we have chlorination of side chain. So here first you need to do Cl2H nu and then you treat it with H3O plus. Next you had Gattermann-Koch reaction. The reagent used here was COHCl in presence of aluminium chloride or copper chloride anhydrous. Right. Then next coming to this part from acyl chlorides. So let me take a different pen here. Yeah. So from acyl chlorides we used R2CD dialkyl cadmium. With nitriles we used Grignard reagent. And then from substituted benzene, this is your Friedel-Crafts reaction, we used RCOCl in presence of AlCl3. Clear? So I hope you have remembered all these reactions. If not, write it again and again, students, and then revise. Okay. So now with this, today's lecture is done. Again, these all things you can revise. So with this, the today's lecture is done. After that, we'll go to now practice some questions. Okay. So once again, you can just see all these reactions that we have written. Okay. So this was a homework question that I have given in my previous class. So anisole on treatment. So what is anisole? OCH3, right? You have anisole on treatment with CHCl3 in presence of anhydrous AlCl3. So this is your Friedel-Crafts as alkylation, CH3Cl in presence of AlCl3, right? So you know this is your ortho-para directing group. So what will happen? You will get OCH3, okay, and at ortho position there will be CH3 plus you will have OCH3, okay, and then at para position you will have CH3. So what we will get? Ortho and para methyl anisole. So correct answer for this question will be option number C. Okay. Fine. Now we'll go to today's practice questions. A lot of questions I have brought for you. So I want all of you to practice answers with me and also comment down the answers. Okay. Now the oxidation of toluene to benzaldehyde by chromyl chloride. So that is, it is telling oxidation of toluene to benzaldehyde, okay, using chromyl chloride CrO2Cl2. So if you remember CrO2Cl2, just now we discussed, it was Itard reaction, right? So let me know how many of you have answered this question correctly. Okay, next we have next reaction. So CH3CN is given, okay, and you have been given with NaC2H5OH. So this is a reducing agent. So what I'll get here? CH3CH2NH2. Okay. Now when you treat, this is your A. Okay. Now when you treat it with HNO2, this gets converted to alcohol. We'll get CH3CH2OH. Okay. So this is B. Next you have copper at 573 Kelvin. Now if you remember, this is a primary alcohol gets converted to aldehyde, right? So CH3, CH2, C double bond OH will get, that is propanol. So we have, one second, okay, one more extra carbon I did. So we'll get CH3COH. This part, okay, this part will get converted to aldehyde group, right? So I'll get CH3COH. Ethanol. So the correct answer for this question will be option number B. Okay. Next, acetone and acetaldehyde are. So we have acetone like this, CH3CO, CH3, and acetaldehyde we have CH3COH, right? So now you see here there are 3 carbons, here there are 2 carbons. So if you remember, isomers are those where their molecular formula is same but structures are different. But here the molecular formula are only different, right? So these are not isomers. Okay, so correct answer is option number B. Many of you might write this as functional isomers. Okay, but be very clear that for isomers the molecular formula must be correct. Okay, fine. Coming to next one. a complex X having molecular formula of C4H10O, okay, X is there whose molecular formula is C4H10 and O, gave on oxidation a ketone. So when you oxidize this one, okay, so for oxidation we can write it like this, a ketone was produced whose molecular formula is C4H8O, okay. Now which of the following is the structure of X? So this is very simple question. If you know that ketone is produced, right? So which type of alcohols give you ketones? So if you remember, secondary alcohols on oxidation give you ketones, right? Secondary alcohols. So you can see this is a primary alcohol. So this cannot be the answer. This is also primary, this is also primary. So these two cannot be the answer. This is a secondary alcohol. So definitely this one can give you a ketone on oxidation. So the correct answer for this question will be option number B, okay. Fine. Next, which of the following reagents will convert CH3COCl to CH3CHO? So preparation of aldehydes, if you remember, from acid chlorides, H2 palladium, barium sulfate, right? So now correct answer is option number C. I want all of you to comment down the name of this reaction, okay. Everybody should comment down when you are watching what is the name of this reaction. Clear? Okay. Next, an organic compound A. So there is an organic compound A whose molecular formula is C8H12, okay. On reaction with ozone followed by zinc gave 1 mole each of CHO whole 2 and CH3CO, CH2, CH2, CO, CH3. The following structure, the structure is, okay. So there are two compounds formed, right? One is your CHO whole 2, that means one compound is like this, okay, and another compound given to you is CH3, C double bond O, CH2, CH2, CO, CH3. So these are the two compounds, okay, and on compounds, when these two compounds are formed, we need to find A, okay. So here I'll tell you some points that you should keep in mind, okay. Now wherever there is double oxygen bond, wherever there is oxygen, connect it with double bond, connect it with double bond, then you will get the product. This is the trick, okay. Now you can see that the options mainly are your benzene ring are the options, okay. So now let us try to do it like this. I will write this compound in a little different way, okay. So let me write it in this way, okay. C double bond O, H, and then I have here where there is this one C double bond OH, okay. Now I want you to write this one also little in a different way so that it can look like what the options are given, okay. So let me write it in this way. We have CH2, CH2, CO, CH3, okay. Now what you have to do, you have to just remove this double bond and collect it, remove this oxygen and connect it with double bonds. So what I'll get, we will have, okay. So this is the compound we are getting. Now find out which is the correct answer here. So if you see, I think this one will give me this product. You can see CH, CH, double bond, CH, CH, double bond, then on both sides we have CH3, CH3, CH3 and then CH2, CH2, right. So correct answer for this question will be option number D, okay. So very simple question, but yes, it needs little trick to understand. So now let us see the next question here, okay. So you have been given with Hg2 plus, H plus and this one, right. So if you remember, this method of preparation is from alkynes, hydration of alkynes. So here actually water is also there, okay. So first of all, if you see, pH is there, okay, then you have C triple bond, C, and then you have CH3, right. So here what is there, addition of water is there following Markovnikov's rule, and in Markovnikov's rule number of hydrogen is seen. But here if you see both the carbons do not have any hydrogen, then we can say which carbocation will be more stable. So if you see, if a carbocation is formed here, this carbocation will be resonance stabilized, right? So this carbocation will be resonance stabilized, so here carbocation will form. So if carbocation will form here, OH will attach here, right? So I'll get like this, COH double bond CH CH3. Okay, after that what happens? Tautomerization will take place. This bond will shift here, this bond will shift here. So I'll get here benzene ring with C double bond O, CH2 and then CH3. Okay, so you can see the correct answer for this question will be option number A. Okay, now coming to the next question here. Ozonolysis of C7H14 gives 2-methyl pentane 3-ONE. So first we can draw this structure, 2-methyl pentane 3-ONE. So I'll draw pentane 3-ONE. Okay, 2-methyl. Okay, 2-methyl pentane 3-ONE. Then so definitely there should be something on this side also. So if nothing is given, we can just assume that there was another carbon here. Okay, so now the next trick, you remember what we have to do? We have to just remove this oxygen and connect it with a double bond. So what will I get? I'll get here one, okay, so we'll get 1, 2, 3, 4, 5 carbons are there. Here there is CH3 and then here we have CH2. Okay, so just now we can number it. So 1, 2, 3, 4. So we'll go from this side, so that substituent will be getting your less number, right? Yeah, so 1, 2, 3, 4. So we have on the second carbon 2-ethyl, 3-methyl but 1-ene. Okay, so the correct answer here will be okay, so 2-ethyl 3-methyl but 1-ene. Okay, this is 2-ethyl 3-methyl but 1-ene. Okay, now what is the another option given to you? 3-ethyl. So that will happen. This one if you number from this side, right? But numbering is wrong in this side because double bond should get your least number, right? So correct answer is option number A. Next, the product A and B in the following reactions are respectively. Okay, so first one is given Br2CCl4. So this one, what does this do? Br2CCl4 adds the double bond, it adds bromine, right? So sorry, so here what will happen? Bromine is added. Okay, after that you have NaNH2 and liquid ammonia. So NaNH2 and liquid ammonia removes HBr. So we can write it like this, it will be more clear. See, you can show it like this. So CH and here there is already one CH. So now with liquid ammonia what will happen? HBr will be removed and HBr will be removed. So here double bond will come. Okay, so I'll get here PH C triple bond C H we should get. Okay, but here you see again sodium is there, so that is why this exists as C minus and Na plus. Okay, so this is your A. So CNA, you can have only one option, so correct answer will be option number B. But again we'll do that part also. There is dilute H2SO4 and HgSO4. So again addition of water following Markovnikov's rule. So what will happen here? pH COH will be added, here double bond and then here H will be added. Then there will be tautomerization to give you pH C double bond O CH3, right? So pH C double bond O CH3. So correct answer will be option number B here. Okay. Next, question number 10. Which of the following alkenes is more suitable for the preparation of butane 2-ONE by ozonolysis? So if you remember, butane 2-ONE should be the product. Okay. Means both the products should be butane 2-ONE. So if same product is required, then you must remember that it should be a symmetrical alkene. Must be a symmetrical alkene. Okay, so if you see here, if I break this bond, so what I'll get? Here one oxygen will come, here one oxygen will come. So it will be like this. If I draw it, here we'll get, okay, and here was this double bond, so I'll get here one oxygen and here one oxygen. So this is 1 2 3 4 butane 2-ONe, 1 2 3 4 butane 2-ONe. So the correct answer for this question will be option number A. Okay. Next question, in the following reactions sequence, the final product is, okay, so first you have KCN. So if you remember, KCN is a simple, there will be substitution reaction, so I'll get CH2, CH2, CN. Right, this we have studied under haloalkanes and haloarenes. SnCl2, HCl, Et2O, then hydrogen, sorry, water. So if you remember, this one will first convert it to CH3, CH2, CH2, CH, double bond NH. Then with hydrolysis we will get CH3, CH2, CH2, CH, double bond O. Right, we will get butanol. So CH3, CH2, CH2, CHO. Now again the question for you, the homework for you, the comment down the name of this reaction. Okay, so 2 name reactions you have to comment down. Okay, so now this is a homework question. 1 mole of symmetrical alkene on ozonolysis gives 2 moles of an aldehyde having a molecular mass of 44. The alkene is. So this is a very simple question. Try this question and then comment down the answers, and in the next class I will be explaining you the solution of this question. Okay. So students, today's lecture is over. We have completed one majority part, that is reactions of preparation of aldehydes and ketones. I have shown you how to draw the flow chart, how to prepare, how to make this flow chart and revise it. So please follow this, and if you have any further doubts, do not forget to comment down. I will definitely address it. Okay, and please answer the questions that I have given you. Okay, just comment down the answers so that I can know that whether you are understanding the concepts or not. Okay, so see you soon in the next class, where we are discussing the major part of the topic, that is chemical reactions of aldehydes and ketones. Okay, from here majority of the questions will be asked. So do not forget to watch the next video of this series, and I hope you are enjoying the lectures and you are practicing daily. All the very best for your KCET 2025 examination. And do not forget our aim, that the target is 60 out of 60 in KCET chemistry. Okay, all the very best, and see you very soon in the next episode of this series.